Is this everyone, or are we still waiting? All right. Gonna try for 30 more seconds, and then we'll start if nobody else comes in. Can't hear you. All right. Okay. I'll do it after lecture. All right. Okay. Hi. So I think it's broadcasting now. I think I did not press the right button yesterday, unfortunately. So there was no YouTube broadcast and no recording. I will try to make a new one, maybe hopefully Friday. Sorry about that. I was asked about quizzes. We do have pop quizzes. It's just that we did not happen to have pop quizzes yet. There might be one on Friday. In fact, it seems very likely because otherwise we would be behind. So again, like no, not a big deal. Mostly it's going to be, are you here or not? Like the first practice quiz. I don't think like everyone is here, so too bad that you don't get the 99 points today, but you maybe could get them on Friday, maybe. Okay, all right. So other questions about project one or anything? All right, so I'll stay for questions after lecture. I think I posted on Piazza yesterday that I was available at 6. I think some people commented today that they want to come today at 6. There's no time machine, but I will nevertheless go to the office at 6. So if you want to come by today, that is also possible. Today I want to do eventually nested loops. You'll see what that is. But I want to start with something that's kind of not super difficult, just a bit of syntax. So, and that's slicing. So to remind you, the way range works is kind of like this. So if you go from 5 up to 10, not including 10 in steps of 2, that kind of means you go from 5 to 7 to 9, and then you're done because the next one would be 11. So you can convert from range to just the list by saying, I want to convert the range to a list like this. So range itself, if you put it into Python, is gonna look kind of like this. So that's not something that we'll do the details of in this course. So it's a range thing in the same way that print is like the function print. So it's like its own thing. But if you convert it into a list, it is going to convert into a list like this. So, okay. So the reason I bring this up is that there is this thing called slicing, which basically goes and takes elements from the list using the same kind of notation as range. So for example, I can say I want to take the elements from the list, starting with element 1 up to, but not including, element 8. So the element at index 8 in steps of 2. And what it's going to do is it's going to give you element 1 and then in steps of 2. So this element, and then this element, and then this element. And then after that, that's element 9. So that's above element A. So you're done. Does that make sense? So you can equally say, I want to start from element 9 and I want to go down to element 3 in steps of -1 in the indices. So what that would do is, well, you maybe cannot count that, but 17 would be the element at index 9. So you get the 17, and then in steps of -1, so you'll get the 15, the 10, the 3, and so on. And sorry, we're going in steps. Yeah, we are going in steps of -1, so it's going to be like this. Down to, but not including 3. So down to, but not including this guy. So that's why it does all of this, but in reverse. Does that make sense? All right. So you can omit the step size. So this would be just starting from element 1 up to element 8. You can also omit the beginning and the end. So here, for example, we are going from element 5 and up to the end. So this is just the ending is omitted. So we're going in steps of 1 up, starting from element 5. So that would be 0, 1, 2, 3, 4, 5. So that's why we start at 4 and we go up to the end here. So up to 18. So we can also omit both the step size at the end. So this is like starting from element 5 in steps of 1 and up to the end. You can also say we are omitting the endpoint here, and we're doing steps of -1. So that would start with element 5 and go down because the step size is negative, and it's going to go down to the beginning. Right. So again, if you look at this, so we're going to start with element 5, 0, 1, 2, 3, 4, 5. And we're just going to do all of this, but in reverse. And that is what you get here. Hello. So, okay. So that kind of implies that if you omit both the beginning at the end, and you say we're going down in steps of -1, what you get is the entire list in reverse. So you start at the end, you end at the beginning, and you go in steps of -1. So that's a way of getting the list, but in reverse. So one thing to note here is we're not printing it. So here, like it has this value, but it's a list, right? So that means that if you say something like L is 5, 6, 7, we can say the reverse of L is L. So the beginning, this is omitted, and we have steps of -1. So that means that we go in reverse, so from right to left. And the beginning is not defined, the end is not defined. So that's like from the end to the start in steps of -1. So that's just going to be the list, but in reverse. So that's a way to create a new list that's the same except in reverse. Make sense? So, okay. So I now want to do a few examples that are more about getting used to like thinking about that, and also just reviewing for loops and while loops and stuff like that. So I want to implement. So this is the next slide, the next thing that's linked from the slides. but I'll do it in Python. So I want to implement slicing notation. So slicing is just what this kind of thing is called. So I'll name it like manual slice. And I'll call it like start and step, and I want to return I just want to return this, right? So I give it the start, the end, and the step, and I want to build a list that's like that, except I want to do it from scratch without using Python's built-in slicing. So, all right. So let's do a first try at that without thinking about what would happen when step is negative. That is actually going to work out anyways. So I'll say, okay, so the result initially, I'll make it the empty list. And then the idea is I'll build up the result by going through my list. So how can I do it? So I can just use, if I get to use the for loop, I can just use the fact that the notation for range is the same as the notation for slicing. So I'm literally going to say for I in range, start and step. And now what do I need? Well, I need to just make a list that's like L at start, and then L at start plus step, and then L at start plus I times step plus 1 times step, and so on, right? And I don't even need to think about it because the I is going to be start, and then start plus step, whether step is positive or negative, and then start plus 2 times step, and so on. That's what the for loop does, right? So I'm just going to append L at I here. Does that make sense? So let me trace that. So 5, 6, 7, let's say. So let's say that I want to do from 1 and up to 3 in steps of 1. Put a breakpoint here. I'm stepping in. So L is this. L is always going to be this. I'm not modifying L. What I'm doing is I'm building up the result. So the result initially is nothing. And now I'm saying append L at I. So I is going to be 1 and then 2, right? Because I'm saying start is 1, end is 3, step is 1. So what I'm appending is L at 1. So I'm appending this guy. Okay, so now result has become this. And now result will become this. And now I'm done. So I'm returning result. Does that make sense? So I started with result being just the empty list, and then I appended 6, and I appended 7, and that's the result that I wanted. So now the result is 6, 7. So that's the same. Is that funny? So that's the same as what is funny. All right. Are people just giggling for no reason? I don't know. So that's the same as L from 1 to 3. What's going on? All right. Okay. All right. So, okay. There is absolutely nothing funny, guys. Okay. Okay, all right. Did you just get the grades and something or? Okay. Say it. I don't know. I think it depends on like, like if it's like extremely low, then maybe that's funny too. But yeah. Okay, all right. So all right, okay. So that's like that. So we can also try going from three, so from two, let's say, down to zero, not including zero in steps of -1. So first of all, what would it mean? So L2 down to zero in steps of -1 is like this, right? So L is 5, 6, 7. So this is like 7, 6, not including L at zero. So that's why the result is 7, 6. Right? So, okay. So now what we're doing is we're saying, okay, so we are stepping in again, like because range and the slicing notation is just the same, it's not even interesting, but we can still do it. So here we have res, it's empty. And now we're saying started with 2. So we're going to append 7. So res is 7, and now I is going to become 1, so we'll append 6. So this is res. So the way append works is you always add to the right. So that's why it's reversed. So, okay. So that's like that. Does this make sense? So let's now try to do it using a while loop. So, okay, so that's like that. So we'll start with the same idea. So the result is going to be empty, but now we have to set I manually. So we'll do I should start with start. So here we'll have a bit of a problem, but I'll just start with while and not say while what. So let's say that we want to append L at I. And now here what we want, so here what we want to do is we want to say I is equal to I plus step. So that's the same, right? So if you go from start to end, it doesn't matter whether the step is positive or negative. It's still going to be the case that you want to update I by saying I is I plus step, right? So maybe you increment it if it's plus, maybe you decrement it if it's minus. Like the plus is going to work either way. You would just add -1. That's the same as subtracting 1 if the step is -1, right? So the problem is here, though, because what we were doing when we were going from start up to end, not including end, is either you go up to end from the left or up to end from the right. And it doesn't really work with the while loop, right? Because if it were that step is always positive, what would you say? Well, if I is smaller than end, then keep going, right? So if you go from start up to end, not including end, you want to say keep going while I is smaller than end. But if step is negative, then it's the other way. You want to say keep going while I is greater than end. Does that make sense? Do you have suggestions for how to fix this? Yeah, yeah. Yeah. So that's also like there is like an algebraic way to get around it, but yeah, like there's no point like so like that is also what I was gonna do. So just say, okay, we're doing an if statement. So if step is greater than 0, then that is fine. That's what we intend. If not, then we'll do it the other way. Okay. Does that make sense? Does it make sense that we have to do it differently depending on whether step is positive or negative? Question? Yeah. In terms of here? Okay. Are you good with this part? Kind of. Okay. So what we're doing here is we are basically trying to do the same thing, but using a while loop, right? So what we're doing is we're saying, okay, so at first, I is going to be equal to start. And then we're going to say increment I by step, increment I by step again, increment I by step again, up until the point where it becomes the case that I is not smaller than n. Yes. Yeah, because our goal, right, is to say we have our L, and we want to let's say we want to do like L1 through 3. So we want for I to become 1, and then we want I to become 2. So that the result is 1 and L at 2. Does that make sense? And the way we accomplish it is we say, well, set I to 1 and then increase it by the step, which is 1 in this case, and keep going until you reach I being greater or equal to n. Okay. So the problem is greater or equal only works for positive step. For negative step, it has to be the other way. Because for negative, you want to keep going while I is greater than that. All right. So, okay. So that's basically it. You can think about like various like algebra tricks to unify this condition. It's possible to do. I don't want to do it now. All right. Questions about this? All right. Okay. So let's keep going. So I am gonna do this one. So this is basically like various list functions that are useful. I'm not gonna do them like in as much detail in terms of let's implement this in Python, pretending that we don't have it. So extend, that's like not actually confusing, but people are often confused by it. So extend basically means I want to append every element of M to L. So that's what L.extend means. So if you look here, the result is it's a list that like L is the list, and then you keep all the contents of L, and then you also add the elements of M to it. Okay, so if you want to think about it in English, it's like extend L with the elements of M or something like that. So if you wanted to implement it, here is a way. So you have L, and what you're going to do is you're going to say, well, take all the elements of M in turn and keep appending them to L. So that's going to be like that. So you'll notice that in this case, I did not have to mess around with indices, with i's. And that's because append just means take all the elements of M and just stick them at the end of L. So don't care about indices, just get me all the elements of M in turn and append them to L in turn. So that L starts out as this, and then it becomes this, and then it becomes this. Make sense? So, all right. So what's the difference between extend and append? Well, you can say L.append M. The issue is that L.append M means take this guy as an element and append it to L. So that means that if you do this, you can. The last element of L is going to be this. Right? So if I do this, that is L. And that means that L at 3 is just going to be this. So to access the 51, I would have to do what? Anyone? Yeah. Yes, L at 3 at 0 is the 51 because we want the element at index 0 of this list. This is this. So L at 3 at 0 is going to be the 51. 3 1 it's going to be the 52. So that is, so L is still this, M is still this. So that is as opposed to L dot extend M, which it can still do. So that would add the elements of M to the end of the current L. So now L is going to be this. So L at 4 is going to be just the 51. And that's this 51. Make sense? So, all right. So, as an aside, you can kind of extend in the middle if you wanted to. So that was a response to a question in class, I guess, at some point. So you can say, so you can do something like this. This is called splicing, as opposed to slicing with a P. So you can say, I want L from 1 up to 1. So that's like replace L from 1 up to 1. So that's like nothing. From 1 up to 1, not including 1, is just empty. So you're saying like at this location, put in 51, 52. You can do that, and that would result in this. Does that make sense? Questions? So, okay. So another thing that's important to know is sorting. So you can create a new list that's the sorted version of L. In this case, in a non-descending order. So all the elements are like, the element to the right is at least as large as the element to the left. So that is creating a new list that's like this. So this is just those numbers, but sorted. So it's important to know that if you say sorted of L, that creates the sorted version of L, but L itself is not changed. So if you say L after saying sorted of L is the same. If you want to save the result, you want to say something is equal to sorted of L. And then M is going to be the sorted version of L is still the same. So in the same way that you say like X plus 5, that does not add 5 to X and store it in X, it just computes X plus 5. If you want to store it somewhere, you say Y is equal to X plus 5. Does that make sense? So there is another sorting thing that does actually modify the contents of the list, and that's dot sort. So if you say L dot sort like this, that does make it so that the contents of L become the sorted version of L. All right. So you can, for example, sort things that are not necessarily integers. So here you have strings, for example, and you can sort them. They would be sorted in alphabetical order, basically. So there is like rules. So kind of with English letters, there's just rules about how it goes. You can compare any sort of characters. So you can, for example, ask if you want to know, like, is A smaller than A? And the answer is false. So capital letters go before lowercase letters, for example. And then digits are somewhere. Okay. So so you can, if you like, so this is like optional at this point. You can query Python for where exactly things are in order. So when you're sorting, what kind of the lower the number is, the lower it is in sorting order. So exclamation points would come before capital A's, would come before lowercase a's. You'll notice that 97 minus 65 is exactly the number of letters in the English alphabet. Haven't checked, but I'm sure it's true. So all the capitals come before all the lowercase. So that implies that something like comes before this one. That is true. That also implies that this comes before, well, that's obvious. It also implies that something like this would also be true. Right, so all the capitals come before all the lowercase letters. Doesn't really matter, like if you want something in particular with mixed case, stuff like that, you should code it in explicitly. You shouldn't rely on remembering that all the capitals come before all the lowercase letters, but it happens to be true. Okay, does that make sense? So to be clear, so you could have a situation that's like this. So that is going to be false. And the reason it's false is that it does it in dictionary order. I don't know actually how many people have used like a paper dictionary. I don't know if dictionary order makes sense. Okay, most people. Why? I guess during a test or something. So like the way it works is if there is a tie over here and there is a tie over here, then what decides which comes before which is the order of the first non-tie. Okay, so here this comes after this because the B comes after A. All right. So okay, you cannot compare stuff like this. So you cannot compare a numeric to a string. That will just get you an error. And that also means that if you have a list like this, when Python tries to sort it internally, it will have to compare, okay, like which should come first, the digit 2 or the string TWO. And it's going to try to compare them using less than, and then it's going to crash because you can't. So if you try to sort this kind of list, it's just not going to work. If you try to do something like this, so L.sort and then assign it to M, that is going to work. It's not going to crash, but what's going to happen is when you try to print M, it's just going to say none. And that's because L.sort, its job is to modify the contents of L. It's not to compute a value. So the default value that's not computed is none. So what happens is L gets sorted, and then you assign the value none to M. So if you try to print it, it's going to print none. If you were to try to print L, you would get 135. Okay, so .sort does this, sorted does the other thing, where you would actually get the sorted version of L in M. So you can add lists. That's like this. So if you add two lists together, they get concatenated in the same way that strings do. So if you say M is L1 plus L2, what's going to happen is L is going to be L1 and L2 stuck together. It's not going to be the other thing that you would think where you would add them element-wise. So NumPy, what you're using for physics, does do element-wise, and then you cannot add two things that are different lengths. Python with normal Python lists just sticks them together. So, okay. You can also, so at this point, I actually never have done it up until this point. I will do it now. So you'll notice that I was trying to be disciplined, and every time I wanted to say like I is I plus 1, I did write it like that. You can write it like this with shorthand, and that is what I'm going to do from now on. So those are the same. This is just shorthand. There is one exception though, which is quite unfortunate. which is this one. So if you do L1 and L2, and then you say L1 plus equal L2, it is going to work like this in the sense of the value is going to be the same, but actually it's not quite that. So if we do, I'm just gonna do it as a preview, uh, and just warn you, like maybe don't do plus equals for less for this reason. So if I run this, you'll get exactly what you'd expect. So it's as if you said L1 is equal to L1 plus L2, right? So that kind of seems fine, right? So the problem though is that really what this is L1 extend L2. So here, so I'm just like a preview, it's going to be kind of like a magic trick of where this can get you kind of confused. So if you say M is equal to L1, and then you say, don't copy this. So I'm saying like M is equal to L1, and then I'll say, L1 plus equals L2. And then I'll say print M and L1. That is going to be this. So that's already a little bit weird. Again, don't copy. We'll do it in more detail later. So here what happens is actually like M and L1 get entangled. And if you change L1, M also changes. However, if you say this, that is going to be like that. That is how the plus equals in lists is not actually literally L is equal to whatever, L1 plus L2. Again, more on this later. I wish Python had not done this. So don't use plus equals for lists. If you want to do extend, do extend. If you want to do something else, do something else. That seems like trouble because if you don't know what you want, well, you'll get whatever you get. Yeah. Okay. All right. I'm not taking questions on this, but if there is any questions about anything up to a minute ago. All right. So, okay. So I think we're going to do this one. So I want to start by giving you a problem, which I call the missing K problem. And then we're going to do a few versions of the problem. So the problem is kind of like this. So we're given a list of numbers from 1 to n, but K is missing. And we want to find K. So the idea is kind of like this. So if I say like missing K, and I have something like this. So like 1, 2, 4, 5, 6, 7 or something, and then I exchange places or something like that. So the answer is supposed to be not touching. So the answer is supposed to be 3 because all the numbers between 1 and 7 are there except for 3. Right? Does the question make sense? All right. So how can we do it? So one thing you can do is you can just sort all of them and then go through the list and see if there is a jump of 2, right? So I can say sorted L is sorted of L. So now the list is going to be something like 1, 2, 4, 5, 6, 7. And now what I'm going to do is just see, okay, so if I'm missing 1, that's a special case. Otherwise, just see if I'm skipping something, right? So, okay. So I'll say if the length of the sorted list is 0, then what's the answer? So if I'm given an empty list, what's the missing k? So I used to have a list from 1 to n, and then I took out one element, and now it's empty. What was the element that I took out? 1. Right? Because it must be like that's the only possibility, right? So like if I'm given an empty list and one element from it is missing, according to this, it's got to be 1. So then I'll check, okay, so if the first element is 2, then what's missing is 1. Right? So now I'm in the normal situation where sorted list at 0 has got to be 1, and at some point there's going to be something missing. So one thing I can do is just like look to the right and see if I'm skipping by 1 or 2. Right? So at I equals to 0, and then 1, and then 2, and so on, up to length of sorted L minus 2, look at the difference between sorted L at I and sorted L at I plus 1. So note that I said minus 2. Why did I say minus 2? So I want to be able to access sorted L I plus 1. Right? The last element is the length minus 1. So therefore, I need to stop when I is the length minus 2. It also makes sense here, like the last pair of elements that I want to compare are those guys. And this is sorted out minus length minus 2, length minus 1. Because the last one is length minus 1. Does that make sense? Okay. So, all right. So I'll just say that. So for I in range, length of sorted L. So I want to go up to minus 2. So that's minus 1 over here. And I'm going to say if I see a gap of 2, then I found my answer. So if sorted L at I plus 1 minus sorted L at I is equal to 2, then what's the answer? So let's do some math. So if I'm going, so this is like the usual situation, right? So I'm going like 1, 2, and then I found the gap between 2 and 4. So when I is equal to 1, the missing element is that plus 2 more. And that's because we started with 0, and also we're missing the next one. Does that make sense? So the trick here, and like the way I figured it out, is just like to look at the example and figure out what it needs to be, right? So if I'm going here like at 0, and I see that, so at 0, I see that the gap is 1, and then I'm at location 1, and I see that the gap is 2, right? So the gap is 2 means that I found my location. So I just did it by plugging in what makes sense and figuring out how to adjust. So I at that point is equal to 1, and my answer is 3. So the answer is I plus 2. I know that if I increase I by 1, then the answer would also increase by 1. So good enough. So that is probably how I would solve it. You can also logic it out, right? So to logic it out, at location I equals 0, we have 1. At location I equals 1, we have 2. At location I equals 2, we have 3, and so on. Right? At some point, there is a gap after location I. So that means that the gap is after the number I plus 1. So that means that the missing number is I plus 2. Right? So you can logic it out, and it would correspond, of course, because math is math, but I would usually just plug it in. All right? So, okay. So that was just the logic. We're almost done. What am I missing? So there's 2 situations actually where there is no gap. One we already took care of. That is when the input started with 2, the sorted input. What's the other one? Yeah. Yeah, so the other one is I got the input like 1 to 3. If the input is 1 to 3, what's the missing number? So I have the numbers 1 to n, 1 is missing, and the input is 1 to 3. What's the missing number? Yes, correct. Yeah. So someone's showing that. Yeah, so it is 4, right? Because, like 1, 2, 3, 4, you take out the 4, you get 1, 2, 3. So if we haven't returned with this for loop, that means that that's the situation, because that's the only thing that could possibly be left. So in this case, what's the answer? Well, if we have the length of sorted L, again, kind of use the method from before. The length of sorted L with 1 to 3 is 3. So the answer is 4. Right? So that would be the solution. Your interview question for today is figure out a way to do it without sorting and without looking at any element more than once. You can do it. It's kind of a clever trick. I will see you tomorrow or on Friday. Bye. See ya. Bye. No. Yeah.
How come you go with I plus one?
So that is because you start where, so the numbers are like 1 through n, but the indices go from 0. So you like one, so it's like plus one plus one. One of the plus ones is because you want to shift from 0, 1, 2, 3 to 1, 2, 3, 4. And then the other plus one is because I is where the gap is coming. So it's like the next number, not the current number. Yeah, which is plus 2. Yeah.
Which is plus 2.
Yeah. Yeah.
Because I thought it was like, I thought this is supposed to be 3, right? And then the I here.
Yeah, so it is supposed to be 3, but when are you going to see the 3? It's like when L is I plus 1. No. It's like when L is I plus 1 minus L is I is 2. So that's here. So I is 1. But the answer is supposed to be 3. Right? Because like this is where you'll be the gap is coming.
So then is I is 1, the 1 plus 1 is 2. That's not.
No, so that's why you say plus 2.
So it should be I plus 2.
Yes.
Oh.
Yeah, that's what I wrote, right?
There's no I plus 1.
Oh, I did. Oh, okay.
Oh,
I said I said I plus 2 though. Yeah, thank you.
Okay,
Yeah.
that's right.
Yeah.
I'm not sure what this means. Switching length of.
So sorted out is the sorted list, right? So
The length of the sorted list plus 1.
yeah, so right, because the situation that we're thinking of is you're getting the list 1, 2, 3, and the answer is 4. So it's like the length of the list plus 1 is the missing number.
Before this one